Hey class, we have made it. This is the last section of the semester. Pretty exciting, right? And this one's kind of short. We kept it a little bit on the shorter side. This one's on parametric equations. Basically, a parametric set of equations is where x and y are functions themselves of a third variable, and we'll call it t. It's pretty standard to use t for a parameter. So let's just jump right into an example. And with this set of parametric equations, what we want to do is graph the curve. What does that curve look like? And then see if we can find a rectangular equation that's the same as that parametric set. So to get a graph, one way to do it is just to make a table of values. It's a pretty good way to get an understanding of what these parametric equations are. So I've picked some t's, and then we're going to calculate the x and y based on the parametric equations. So if t is equal to 0, I'm just plugging in that 0 to where I see t to get the x and the y. So for the first one, I'm putting the 0 there, 7 sine 0. Well, sine of 0 is equal to 0. 0 times 7 is 0. Then I'm going to put the 0 there to figure out the y. And that's 7 cosine 0. Cosine 0 is 1. 7 times 1 is 7. I'm going to do that for each of the t's. And notice t is defined as between 0 and 2 pi. So I'm just kind of doing some special ones that I know would be pretty easy to calculate. Pi over 2, the sine of pi over 2 is 1. 7 times 1 is 7. Cosine of pi over 2 is 0. 7 times 0 is 0. Right, etc. Plug in pi, you'll get 0 here. But the cosine of pi is -1, so you get -7. 3 pi over 2, the sine of 3 pi over 2 is -1. Cosine is 0. And then finally, 2 pi is the same as 0, because it's the same location on the unit circle. If I plot those points, I can see what the graph looks like. So I get 0, 7, 7, 0, 0, -7, and -7, 0. You even get an order to it, right? You can see how it kind of goes in that clockwise order around, right? So that'll be another step, and it turns out this is going to be a circle. Right? If you're not sure that it's a circle, you can plot some more points if you're worried that's going to be a square or something. But these, we're talking about circular functions. That's pretty easy to assume you're going to get nice, smooth, round curves. Okay. Now, can I come up with a rectangular equation? So a way to do that is use some identities and equations that we've used in the past. So the trick I'm going to use here on this one is I'm going to take that first equation and square both sides. So I'm going to take in square the x and then square the entire 7 sine t. Then I'm going to distribute that square. So 7 squared is 49 sine squared t. And then I'm going to solve for the sine. So then I'm just going to write this as x squared over 49 equals sine squared t. Okay. Now let's also do that for the y equation. So y squared is equal to 7 cosine t squared. So I'm going to get y squared equals 49 cosine squared t. So y squared over 49 equals cosine squared. Okay. Now, how am I going to combine these? Well, I have an identity. Let's use our trigonometric identity, my favorite one. I don't know if it's my favorite, but for this problem it is. Sine squared plus cosine squared is 1. I know that's a fact. Now I'm going to replace sine squared with the rectangular version in this problem, x squared over 49. Cosine squared is y squared over 49 equals 1. Now I've gotten rid of the parameter and the trig functions, and I'm left with a rectangular equation. Multiply through by 49, and we get x squared plus y squared equals 49. which from algebra you can identify as a form of a circle with a radius of the square root of 49.7. So now we're certain that we got that right, that graph. Okay, so that's how those go. Could try another one here. X equals 4 sine t, y equals 5 cosecant t. Ooh, okay, so what if we plug in 0? Well, plug in 0 where the t is. T is 0. I'm going to get 4 sine 0, which is 0. If I plug in 0 for cosecant, going back to unit circle, cosecant of 0 is actually undefined. So this would be undefined. Continue. Pi over 4, so I'm gonna get a decimal. Pi over 4, same as 45 degrees. I'm gonna plug that into my calculator, and I get 2.8. 5 cosecant pi over 4, plugging that into my calculator, or 5 divided by the sine of 45 degrees, 7.1. Plug in pi over 2, the sine of pi over 2 is 1, and multiply that by 4, that's 4. And the cosecant of pi over 2 is also 1, 5 times 1 is 5. 3 pi over 4, it turns out you get the exact same. Again, if you want to just do this in degrees, you can, right? 3 pi over 4 is 135 degrees. And then pi, you get the same as 0 in this one. Okay, so we pretty much have 3 points, and we note that it's at 0 is undefined, and then we have 3 main points, and that one's the same. So the undefined, you're going to get an asymptote. And then we have 4, 2.8. So you're right about there. What did I, ignore me, that's not right. 2.8, 7.1. Okay, 2.8, 7.1. Ooh, let's see, where's that going to be? 2.8, 7.1. Looks like we're right about there. And then we have 4, 5 there, and that stops. So this graph looks like it's heading in this direction. I could plot some more points if I wanted to see more of the graph, but that's what this looks like. And it stops there. I mean, because of the restriction of the t. The t, it says just go from 0 to pi. So I can't go any further than that. Okay. Now let's get the rectangular form of this graph, which might help verify that this graph is indeed correct. So let's do this little idea. I'm going to divide both sides by 4. So you can kind of see what I'm doing. I'm isolating the trig function. And then let's leave that alone for a minute. And now let's work with the other one. I'm going to use a trig identity. Cosecant is 1 over sine. Okay. And then now I know that sine t is x over 4. And there's a sine t right there. So let's take the x over 4 and plug it in. And that gets rid of trig functions and t's, and you're just left with x's and y's, which is what we're after because we want rectangular form. Now just multiply by the reciprocal of the denominator. So we have, let's go over here, a little more space. Y equals 5 times 4 over x. And so we've got y equals 20 over x. Okay. And then it also said specify, oh, I forgot to do this on the last one, specify the interval for which this is defined. And that's really from our table and our graph. So this one on my x is just going from 0, not including 0, up to 4. So x in the interval 0 to 4. looking at where it was defined on these X values. It stopped at 4. That was a really messy scribble. Let's just get rid of that. 0 to 4 is where it was defined. In the previous one, it was -7 to +7 on the x-axis. So I could specify that it's this interval. Cool, how's that look? All right, I'm gonna pause for a moment, take a water break, and I'll come back with the final video next segment. Okay, hope all is well with you. Talk to you later.